Hey there, welcome back to another video of our CCNA video series by PyNet Labs. And in this video, we're going to start our journey with routing. So till now, you are pretty familiar that how you can configure IP addresses on the router. I have made you familiar with the operating system of Cisco, which is Cisco iOS. And I've made you familiar as well that how we can use or how we can make use of DHCP or Dynamic Host Configuration Protocol, a protocol which provides an IP address and subnet mask and DNA and default gateway configuration to the endpoints that we can connect with the routers. And it's not possible only to configure DHCP, as you all know now, only on router, but you can also have a server that acts as a DHCP server independently apart from the router configuration. So moving on, it's actually time now in order to learn about how a router makes its forwarding decision based on different, I would say, protocols that it can configure itself with, and based on the configuration that you can deploy onto a router or so. A router actually decides that where to forward the incoming traffic onto the directly or indirectly connected networks over there. So we'll be talking about static routing in this video and various other routing types of how we can implement static routing. So let's go ahead. In this section now, I'm going to first build up a topology, and if I give you a scenario how we're going to move ahead for understanding static routing is in a way that we'll have kind of one router at the beginning, and then we'll connect that particular router with another router. So you can say that these two routers can create two different topologies. And you can say that, for example, if I take a switch that can be connected with that router 1, and then that switch can again be connected with different endpoints. So let's say this is user A, user B, and user C. And this entire local area network that you see over here might be using a network, let's say 192.168.1.0/24. And then you can say that there can be another network where a switch connects again different nodes, and you can say these users are D, E, and F. And then this local area network can actually be 192.168.2.0, okay, /24. Now it's pretty obvious that both of the networks are not connected to the same router. That's why the communication between them might be limited at the beginning. So how the process actually is going to work, that whenever the traffic is going to reach out from one location to the other location, for example, if it is supposed to travel from A to D, then usually this communication is not going to be directly completed. This communication needs to be done by taking the help of the gateway there. So what happens when the endpoint A decides that it needs to reach out to an endpoint which has a name D? So before reaching out over there, or before leaving the computer or whatever device that you're on, your PC actually, or your device actually looks into the local routing table, and it checks whether it knows about different information that the PC is going to gather from the device. So the PC, of course, as we have learned into the OSI reference model or even the TCP/IP model, that what all are the information that is collected from the device. So if I give you a rough idea about that, then you can say that the device is going to collect the information about source IP address, is going to collect the information about destination IP address, then it's going to collect information about source MAC, and it's going to collect the information about destination MAC. So over here, let's say that our source IP address, for example, is 1.2, 192.168.1.2, and the destination IP address is 2.2. And then you can say the source MAC address, let's assume that it is AA, and the destination MAC address can be said as DD. Now when all of this information is actually gathered, then the device checks into the local routing table whether the device knows about that particular information or not, and it checks that the destination network, which is 2.2, is not available into the local routing table, correct? Now upon getting to know about this, the host will also, as it's like IP configuration parameter, the possibility is it will have IP address configured on it, it will have subnet mask configured on it, and it will have default gateway configured on it. And when it comes to a conclusion that it doesn't know about the destination network by itself, then what it does, it forwards the traffic onto the router, which is actually acting as the gateway as well. And the information about that gateway is also configured onto the local device, okay, with the help of either manual configuration, or it can be configured with the help of default gateway as well. Make sense? Now when this router receives the information, then you can see that a router also maintains something called a routing table, right? And when this routing table is going to be maintained by the router, then the router will consist some of the information into the routing table, that which are those networks that it knows about. You understand that? And so is going to be maintained by R2 as well. So R2 will also have its own routing table that will consist its own routes that it knows about. So as a basic scenario, you can see that router will be needing to forward this particular traffic onto the other router in order to make that particular communication successful. And for doing so, you also need to make sure that R1 and R2 can communicate together. And for the same purpose, you need to keep them into the same networks there. So you can say we will be creating another network that says 192.168.3.0, for example. And then we'll be configuring 3.1 at one end, and we'll configure 3.2 on the other end of that router, so that the communication between these two devices is actually made successful from here to here. So the router is then free to forward the traffic to R2, and when R2 receives that traffic, then it will be able to forward the traffic over here. So this is how the scenario is going to be, and the concept that we call it as static routing, because there are different modes of how you can implement that particular routing. But you can say the one that we are actually looking for as of now is called as static routing. So let's go ahead and see how the implementation of static routing is done, and then I'll also ensure you that you understand how static routing actually works, because everything that we're going to do over here is static. So talking about different routing protocols, when we actually think about it, then there are different routing protocols that are available, and these routing protocols are actually grouped into I would say multiple types. So if we talk about routing protocols, then the first type of routing protocol, of course, is static routing. Okay, and the second type of routing protocol is dynamic routing. You understand that? So under static routing, you can implement plain static routing, or you can implement default static routing as well, and you can implement the third type, which is called as floating static routing. So we're going to explore all these three types of static routing, and then if we talk about dynamic routing, then dynamic routing also has different parts in it, where the categories under dynamic routings are divided in a way that you have distance vector dynamic routing protocol, which is routing information protocol, which is no longer available into the curriculum of new CCNA that Cisco has came up with, but we're going to cover that for you in this video series. And then the second type of routing protocol that we have is advanced distance vector. So you can say this advanced distance vector routing protocol is also there. This is another type of the thing, and the protocol which comes under this particular category is very famous, called Eigrp, Enhanced Interior Gateway Routing Protocol, which again have been removed from the official curriculum of Cisco's CCNA course, but we're going to cover that for you as well. And then we have the third type of routing protocol, which is called as link state routing protocol. And the example of this routing protocol is the very well known and well deployed OSPF, Open Shortest Path First, which is part of the official curriculum, and we're going to talk about it in depth. Then there is another type of protocol that we actually use, which is none of our concern for this particular course, but I'll let you know about that it is called as path vector routing protocol. And BGP Everyone might have heard about it, that BGP, which is called as a border gateway protocol, comes under the I would say comes under path vector routing protocol type. Okay, and these types again are divided into two categories. Okay, some of them are called as IGP protocols and some of them are called as EGP protocol. IGP stands for Interior Gateway Protocol, meaning that when you are implementing routing for the same organization or within that organization, we use protocols that comes under these category IGP, which is called as Interior Gateway Protocol. And the protocols that comes under this IGP category are RIP, you can say EIGRP, OSPF, or you can also say that static also comes under this particular tag. And when you talk about EGP, which stands for Exterior Gateway Protocol, then or External Gateway Protocol, you can call it as well. This particular protocol, this protocol is used for connecting multiple sites of your organization or multiple organizations together. So as BGP is the backbone of the internet that we use today, it connects all the organizations that exist into the world. Okay, so that's why BGP comes under this particular category, that it's a EGP protocol. Okay, so these are the different types of the protocol that exist into the world today, and there are others as well, but we are concerned about these only, okay, as the beginners CCNA course. So we're going to start our thing with the very first protocol, that is called as static routing protocol, and then I'll give you a glimpse about how you can actually make use of that into your production scenario as well. So let's go ahead, create a topology over here, and we'll be configuring that topology with all the basic minimum requirement of configuration that you need, which is going to be the IP config and DHCP config, and then we're going to implement static routing over here. All right. So as part of our topology, we're going to have a couple of routers, and those routers will be the 4321 series routers, which are ISR routers, and we are going to put those routers over here. Now in previous videos I have made you familiar enough that how to use packet tracer in order to build up your topology, and I hope you are practicing that thing daily there. Then we're also going to use a switch, and the switch that we're going to use here is going to be 2960. So I'm going to put up a switch here, and we at CCNA level, we are not really concerned about which models can we use and which models we cannot, because these terms of checking the capabilities of the router comes into play when you actually go deeper into the concepts of how you can fine-tune the performance of your devices that you're working with. So far as you are dealing with CCNA, we are only concerned about getting to know about if we have number of modules or enough number of ports that are available onto the device so that we can connect multiple devices in our topology. So after having a couple of devices over here, we are going to place some couple of PCs as well. So I'm gonna put a PC1 here, and let's say I'll also put up a laptop there, and then I'll put up a PC and a laptop here. Okay, and for connecting them together, we are of course going to use a cable that is called as automatically choose connection type, which is the first cable. So by going into this section, I'm going to use this cable, and by selecting over it, you can click on this router and then you can click on the switch, and there you go, the connection has been made between the gigabit port and to the fast Ethernet port over there. And then after that, I can now for like making multiple connections, I can just press control on my keyboard and then select the cable, and then I can leave the control so that I can do multiple connections at a time, like this and like this. So I don't need to go back to the selecting the cable again and again. And then I connect this topology as well, like this, and then I connect both the routers together there. All right, so as we have our topology ready, we are going to also put some notes over there so we understand that which network is being used by what kind of topology. So we have 192.168.1.0 over here, then we have 192.168.2.0 over here, and we have 192.168.3.0 over here. Make sense? And then after that, what we are going to do, we will be configuring these routers with IP parameters and with DHCP parameters that they need to be configured with. So over here, I'm gonna create, or I'm gonna use, I would say, click on the device, and then after clicking on the device, I'm going on to CLI. So this is our router 0. You can see that we have multiple. This is where you can see your topology, and this is where your router is situated at. And over here, as this router is up, you can see that it asks, as it doesn't have any startup configuration loaded into it, so it asks you, would you like to enter into the initial configuration dialog box? So I say no here, and then I say enable, and then configure terminal. After going into the configure terminal, of course you guys know that we need to go into the interface that we're working with. And which interface are we working with of the router? You can verify that onto the router itself, that the interface is gigabit 0/0/0, which is connected to the switch, and the IP that we're going to configure on this interface is 192.168.1.1. Of course we cannot configure 1.0 because that's a network ID, so you're going to use the very first IP address that is available from the network, which is 1.1. So here we go and say interface gigabit 0/0/0. And by going into this interface, we are going to perform a command that says no shutdown. And then after performing this no shutdown command, then we are going to configure an IP address over here by using a command called IP address 192.168.1.1 along with a subnet mask. And then we're going to get out of that interface configuration mode, and we'll be into the major config mode here, where we are going to create a DHCP pool for the same. So let's say that the department that we are working up over here, this is, you can say, called as sales department. Okay, and this can be your marketing department. Make sense? So we will go on to the router again, and then we will also give it a host name called R1, right? And then we will say IP DHCP pool sales in order to create a DHCP pool there. And then we will say the network that the DHCP pool is looking forward to provide it is going to be 192.168.1.0 along with 255.255.255.0 here. Make sense? And this needs to be network ID all the time. It cannot be any IP address or so. Okay, so this needs to be a network ID that about the network that you specify into the DHCP config there. Okay, and then we specify the default router as well, so that this IP address that you're going to specify into default router section will be acting as the gateway IP address that the DHCP will be providing to the endpoints. And it says, okay, there's a syntax error that I used an extra dot here, so I'll fix that thing and reuse this command, and there you go, our configuration is all done. Now what we will do, we will go on each and every device there, and we will verify whether these two endpoints get the IP address from the designated DHCP or not. So we'll need to click on this particular device, and then the PC0 window opens up, and we can go into the desktop section of this, and over here we can click on IP configuration. So when you click on this IP configuration, there are two options in order to configure IP address. You can configure it by either static or by DHCP. So we're going to click on the DHCP here, and it says requesting IP address, and it says DHCP request successful there. And you can see here that the IP address, subnet mask, and default gateway configuration has been done automatically from a DHCP server. Make sense? And we're going to follow the same thing onto the second PC that we have over here by clicking on to the laptop and then going into the desktop window, and then IP configuration, and then DHCP. And upon clicking on that, you will get a DHCP IP configuration there as well. There you go, 192.168.1.3 along with 255.255.255.0 and the gateway information here as well. Make sense? So after getting it done, we'll move on to the next router, and we're going to configure our second router over here that is available, and we'll do that by clicking onto this router and then going into the CLI. And there you go, our router is up and ready for the configuration to be done for the second network that we're going to use, which is 192.168.2.0/24. And you can see that in router 1, there you go, it asks you, would you like to enter the initial configuration dialog, and as always we're going to say no there. And then we'll go into the enable mode and then configure terminal mode, and then after that we're gonna say our host name is R2 over here, and we're gonna say interface gigabit 0/0/0, the interface that we're connected with. You can still verify the same by going into the topology, and there you go. This is the interface on which we're going to configure an IP address, which is a part of 2.0 network. So again, here we're going to use the first IP address, which is 2.1. So we'll turn on this interface first, and then after turning it on, I'm going to say IP space address 192.168.2.1 along with the IP address. And then we're going to say exit, and we will be getting out of that interface configuration mode. And here we're going to create a DHCP pool for that, saying IP DHCP pool marketing, and then specifying the network parameters that we are using 192.168.2.0 network along with the subnet mask of this. And then we will say default router is 192.168.2.1. and there you go. We'll be good with the configuration there. Then we will go on to the endpoints that is connected onto this topology, and we will see whether these gets configured with the IPs or not. So we'll go on to the device, and then this is PC1, going into the desktop IP configuration and clicking on DHCP. It should get the IPs. There you go. 2.2 has been configured with the subnet mask and the gateway information that is desired there. Then again we will go on to the topology, and then we will click on the second device, and then we will go to the desktop and IP configuration of this laptop and saying DHCP, and there you go. The DHCP again is configured successfully here. So you can see that our Ethernet network has been configured completely. Okay, the routers have their Ethernet IP addresses or their LAN IP addresses and the DHCP config, and the endpoints also are configured with the IP address and other parameters that they need to configure, that they need to be configured with. And if I check whether these devices can actually communicate with the router or not, then for that what you can do, you can open up your PC settings, you can go to your command prompt, and from command prompt you can use ping utility, and you can try to ping your router, which is the gateway as well. So you can say ping 192.168.1.1, and there you go. You are able to communicate with your router now. Makes sense? And same can be ensured on the other network as well by opening up a device. Let's say we are opening this laptop here, and then by going into the command prompt of that laptop, we can say ping to the gateway of the next or the second network, which is 2.1, and there you go. You are able to communicate with that device. So of course the communication is ensured here, and we don't need our switches to be configured with any information as of now. Okay, we'll be coming down to the layer 2 configuration or switching part later in this video series. So here we go. The next thing that we need to do is make our gigabit Ethernet 0/0/1 on both the router configured into a network that we're gonna use, which is 3.0. So we're gonna use 3.1 on this side, and we're gonna use 3.1 on the other side here. So what I'm gonna do, I'm gonna go into the 001, turn that interface up, and configure an IP address, which is 3.1 over here. So I'm gonna click on this router, and then after I click on this router, I'm gonna say interface gigabit 0/0/1 there, and then say no shutdown, and then say IP address 192.168.3.1 along with the subnet mask, and there you go. That's the only thing that you need to do. And then I can go on to the other router over here. Now you see the interface over here have not came up even though we have applied a no shutdown command on this interface. So this happens with point-to-point connectivity when you connect multiple layer 3 devices at one time or multiple routers together. Then until unless both sides of the interfaces are up, till then the interface will not come up there. Make sense? So then we're going on to the second router, and then on here I'm gonna say interface gig 0/0/1 and say no shutdown, and say IP address 192.168.3.2 along with 255.255.255.0. And there you go. You can take an exit over there, and then you can see after hovering the cursor, oops, just a minute. Yeah, there you go. So after hovering your cursor here, you can see that the gigabit Ethernet 0/0/0 is now configured with 192.168.1.1/24, and gigabit Ethernet 0/0/1 is now configured with IP address 192.168.3.1, and so will be configured the other router as well with the interface parameters. See there, 2.1 has been configured and 3.2 also has been configured there. So I can ensure now that the router 1 and router 2 can actually communicate together. So if you go here and if I say take an exit there and say, as ping is kind of a command which is used at privilege mode, so we say ping space 192.168.3.2, and there you go. The first packet was dropped for the ARP resolutions there, and then all of the other packets were success. If we try that again, then everything will be success. Make sense? So the communication is working just fine over here between the devices. But if we try now for this device to communicate with the other device, this will not work. And why is that? Because if you check the IP parameters, you can see that the fast Ethernet 0 interface of that particular PC is configured with 1.2 IP address. And if we check on the other end, then you can see the other PC is configured with 2.2. So if I try to communicate, opening up that particular PC, going into the command prompt and saying ping 192.168.2.2, then you can see destination host unreachable. And this is the I would say error that you're gonna get. You see, request timeout, destination host unreachable there. So there are no packets that actually received from the device, and it says 100% loss. And why is that? Because if we check the connectivity, then you can see that after this device not finding the I would say destination network information into the routing table, then it's going to forward that particular traffic onto the router. And if I even check by opening up the router, see, this is basically the router that we have, and if we check this router by going into R0, you see, we can check that routing table of the router by using a command called show IP route. The show IP route command shows you the current routing table that the router possesses of. So when I say show IP route here, you can see over here that these are the routes that the device actually knows about. Make sense? Now over here you can see that the first network that the router knows about is 192.168.1.0, and these are some of the what you need to be concerned about is C. To avoid the local configuration, this L actually gives you, see, L stands for local, which means which is the IP address configured onto the interface. So it gives you the IP information, the L route gives you the IP information, and the C route gives you the entire network information that it knows about. So you can see that the router currently only knows about a network that says 192.168.1.0, which is directly connected with gigabit Ethernet 0/0. And the other network that the router knows about is 3.0. Make sense? So it doesn't have any idea about where is this 192.168.2.0 network, which is the destination for our PC there. And if I verify the same onto the other router by going onto R1, I can click on R1 and I can perform the same command. Now here's the thing. When you want to execute privilege mode commands into the global config mode, because it's kind of frustrating to go back and forth again and again to execute some of the commands there, right? So if you want to execute the show commands or the other executable mode commands there, or privilege mode commands there, or enable mode commands there, you can use something called show, or you can use something called do before the show command. So always use do before executing any command that is originally made for the enable mode there. So you can say or execute the same command by just appending do before the command, and you can say show IP route here, and when you execute this command, you can see that these are the two networks that the router, which is R2, is currently aware about. So you have 2.0 network here and you have 3.0 network here. Make sense? So you can see now that in this particular topology there are two types of networks that we currently have. Okay, and if we look at into that, then the first type of network that you know about is directly connected network. Okay, directly connected network. And the second type of network that you know about currently is called as indirectly connected network. These are the, I would say, networks that you currently have in your network or in your topology. So what is this directly and what is this indirectly connected network? You see, if I look at the perspective or with the perspective of R1, then R1 is currently using both of its interface. Okay, it's using this gigabit 0/0/0 and it's using this gigabit 001 as well. And gigabit 000 is connected to a network which is 1.0, right? And gigabit 0 is connected, or 0/1, which is the other one, is connected to a network called 3.0. And if I look at with the perspective of the other router, which is R2, then its gigabit 000 is connected to a network called 2.0, and the other one is connected to a network called 3.0 again. So what happens here, both of these networks are actually called as directly connected network, these and these. Okay, so for R1 you can say that network 1.0 and network, I would say, 3.0 is actually directly connected networks. Makes sense for R1. And if I look at R2, then R2 has 3.0 and 2.0 as directly connected networks there. You get that? So which means that whenever you look into the routing table of a router, and if you found any routes, or if you find any routes that are actually called as, I would say, that actually gets referred as C tags or with C tag, then these are the directly connected networks of that particular router. Okay, and directly connected networks are the network which doesn't needs to be known by any other router. These are locally stored onto the routing table. Make sense? So by implementing static routing, what static routing actually does for you, by using static routing, you actually let the other router know about your directly connected networks. You understand that? What you're gonna do, you're gonna let the other router know about your directly connected networks. And how do you do it? This particular process actually is done manually or statically onto each and every router, and that's why we call it as static routing. So what we're gonna do in this particular scenario is we're gonna go on to each and every router. We're gonna go on R1 and we're gonna configure a static route there for 2.0 so that R1 knows about where is 2.0 situated. Make sense? And on R2 we're going to configure a static route for 1.0. So we're going to tell R1 that how to reach out to 1.0. And once both of these routers know about each other, then the PCs or the networks will be able to communicate with each other there. Make sense? And the static route is going to update the local routing table about the information that it knows about. You get that? And so let's go ahead and try to implement the static routing onto our scenario. So what I'm going to do, I'm going to go on to R1 again, and I'm going to add a static route over there for 2.0. Make sense? So I'm going to go here and I'm going to say IP, or go into the configure terminal. And by going into the configure terminal, we use a command that says IP space route, and we specify the indirectly connected network ID, the network ID of the network that we want to add in our routing table. And what is that? For R1, the indirectly connected network ID that we want to add is 192.168.2.0. Correct? We are on R1 over here and we want to add the route of 2.0 into our routing or into our routing table. So you can go into the router and you can specify that this is actually the network that we want to add about. and then we specify the subnet mask of that network as well. So we say IP route 192.168.2.0, which is the indirectly connected network, again I'm telling you, and the subnet mask of it. And the last information that you need to add is the exit interface, meaning that when the R1 is adding the information, it is actually making its brain, the routing table, aware about how to reach out to the destination network. And we specify that by telling the router that, hey there, whenever you have a requirement of reaching out to 2.0, then you send all your traffic onto the exit interface that faces towards R2. And what is that exit interface? It's a gigabit 0/0/1. Make sense? So we're going to specify the exit interface of that particular router, that by using which local interface it can take an exit so that it reaches out to R2, where the 2.0, the indirectly connected network, the destination, is situated. Make sense? So we're going to specify over there that we want to add a route for 2.0 along with the subnet mask, and the exit interface, or the interface on which the traffic can be forwarded for this network, is gigabit 0/0/0. So after specifying the exit interface over here, then you hit enter, and it however gives you a note that says default route without gateway. If not a point-to-point interface, then it may impact performance, which means if your device is not connected directly in a point-to-point fashion, and it is connected with some other type of connections which are like old technologies, frame relay or so, where the connection between multiple routers was used to be a shared network or a point-to multi-point network, then that was kind of impacting network issues. But we have a point-to-point network over here, and after configuring this, you can check your routing table. Now in the previous example, you can see that the routing table doesn't consist of any route here. But once I check now by executing a command, let's say do show IP route, you can see, there you go, there is a new route that has been added into the routing table, which says 192.168.2.0, and it says it is directly connected by using gigabit Ethernet 0/0/1. So what's this particular router is going to do now? Whenever it receives any traffic from its endpoint that needs to be forwarded to 2.0 network, it's going to forward that traffic onto this link, and then the other router is going to receive the information. Now here's the thing, static routing doesn't actually work by just configuring or by just letting the indirectly connected route on your router. It also needs to be configured on the other side as well, because when the router sends the traffic onto the other router, then how it affects that whenever this particular router is going to receive that traffic, which is actually coming from 1.0 network, then it's going to check that what is the source IP and what's the destination IP. So as of now, if I check the routing table of our R1, then you can check, or you can see that there is no information about 192.168.1.0 as of now into the routing table of R2. So what it's going to do is going to drop the packet saying that I do not know this source and I don't trust this information. So for the same thing, we need to also implement static routing on this router as well by going into the configure terminal, and then I'm going to say IP space route, and here on R2 we're going to add a network which is 192.168.1.0 along with specifying the subnet mask information and the exit interface over here. Now what's the exit interface? It's again same here, which is gigabit Ethernet 0/0/1. Make sense? So I'm going to go on R1 and I'm going to say gig 0/0/1 here and save it, and then again we can check the routing table if it has the new route. Now show IP route, and there you go, you have a static route which has been injected into the routing table now, and both of your router knows about the indirectly connected network that you had. Make sense? So you know about a network that's here, you know about the network that's here as well, and then now as both of your router knows about the every route that is existing into the topology, I can go onto this PC and I can specify here, or I can say ping 192.168.2.2, and there you go. It will start discovering the ARP resolution thing, and after it discovers it, it will try to send the traffic again and see if it works there. Okay, you're having some issue there that it's still saying request timeout. Let's see what that issue is. If you check our, let's check our PCs are connected with the IP configurations. And if I again try to, there you go. It might have been the network issue there, though it's not a real network, but yeah, you can check that the communication from this PC now, which is PC0, is happening from the PC to the other PC at the other end to 2.2. So if I again send that traffic, there you go. The communication between these are successful. And if I go and open up some other, I would say laptop. Let's say I open up this laptop, and from this laptop go to command prompt, and over here we try to communicate with something called 192.168.1.3, which is the other laptop. And here, let's see, yeah, first time for ARP resolutions the traffic might be failed here, but if I again check that out, okay, we'll check if we have 1.3 available. Let's try it for 1.2. Yeah, there you go. With 1.2 the communication is happening. Do we have 1.3 configured on something? What's the IP address of this router? Yeah, this is 1.3, and if we try to communicate from this 1.3 to the other end, ping 192.168.1.2, let's say over here, and you can check that 2.2 is the IP address that we actually need to check, and there you go, the communication is working. And if we check it between 2.3, the communication is also working over here. And now if I go on to the other laptop, which is, I would say, from the topology this laptop, and check, go to the command prompt and say ping 1.3 over here, then you can check over here that yeah, the communication is actually working here. Makes sense? So this is exactly how you implement static routing, and now each of this PC is communicating with the other one, and that's what we actually had to look into. So by implementing static routing, you actually add manual routes into your routing table, and by adding them you can make your network communicate with each other. In the next video, we're going to talk about how you can implement default static routing or static default routing, and the other type of routing, which is floating static. So stay tuned over there. I hope you enjoyed the content of this video, and do practice by using the packet tracer for this concept, and make yourself good with static routing. Thank you so much for watching. I'll see you guys in the next one.